Okay, so now we're going to do some examples of finding angular speeds and linear speeds. So the first example says a water wheel shown, so picture a water wheel. So a water wheel completes one rotation every 5 seconds. Find the angular speed in radians per second. So it completes one revolution every 5 seconds. Okay, so we've got this water wheel. So if you ever watched Little House on the Prairie, you know, they have a water wheel on the outside of the mill that runs their bandsaw that cuts the lumber. Okay, so now I have this water wheel, right? And it goes one revolution every 5 seconds. So I'm going to write that. So it's one revolution for every 5 seconds. Okay, that's the rate at which it's turning. Okay, so now I want to find the angular speed in radians per second. Okay, so radians per second. This is easy, right? Well, what's one revolution? It's a circle, right? What's one revolution in radians? One revolution is equal to 2 pi radians every 5 seconds. Well, let's stick that in our calculator. What do you get? Well, that gives us 1.257 radians per second. So 1.257. That's it. Okay, let's do another one. Now in this one here it says a bicycle has wheels 20 inches in diameter. All right. Oh, so let's do... So diameter is 20 inches. Okay. A tachometer determines the wheels are rotating at 180 RPMs, which are revolutions per minute, right? So it's going at 180 RPMs per minute, right? Revolutions per minute. All right, good. Now, find the speed the bicycle is traveling down the road. So this is linear speed because we're saying how much of the arc length, which translates to the amount of the road that it's covering, right? It's the same, okay? So we want to convert this to linear speed. Well, we're going to write this in angular speed and then use our formula to convert it to linear. So let's do that. So revolutions per minute, so that's 180 revolutions per minute, right? And so we want the speed of the bike, and I'm assuming they want miles per hour, right? I mean, typically that's the way we do it. So I'm going to do miles per hour. So 180 revolutions, so again, I'm going to say that 180 revolutions, so how do I do this? Well, I'm going to use conversion factors because I know one revolution, because my goal is miles per hour, right? So I need miles on top, hours on the bottom. So again, I know that 2 pi radians is equal to 1 revolution, right? So I'm going to use my unit ratios. Okay, so 2 pi radians okay, per revolution. So revolutions cancels with revolutions. So now I've got radians per minute. Okay, but I need radians per hour. Right? So radians per hour, so I'm going to multiply this, so I need to get rid of the minutes here, so I need hours on the bottom. So I'm going to multiply it first by 60 minutes. Oh, okay, no, just one. So 60 minutes for each hour. So now minutes cancels with minutes. And so I got hours on the bottom and I got radians on top, and so that will give it to me. So if I multiply across the top and the bottom, so I got one on the bottom, so I get 180 times 2 pi times 60, and that's going to give me 360 pi radians per minute, right? Again, I'm not gonna do my calculation until the very end. I'm not gonna estimate things. I'm gonna keep everything exact until I get to until I get my final calculation. Okay, so this is going to equal 2 times. Hold on a second. Nope. I didn't go far enough. Yeah, I could do that. Let's. So that's going to be. Oh, you know what? Let's just keep it this way. Let's just keep it at radians per minute for now. We can always convert it to miles per hour later on. It doesn't matter, but let's just stick with what's going on here. So this is going to be 360 pi radians per minute. Okay, so all I did was I don't want to change it to hours yet, so I just kept it at radians per minute. And so now what are we going to do? Okay, well now we're going to use our formula. Okay. And the formula for linear speed, remember, is the angular speed times the radius. Okay, now, radians is a unitless, so that's going to be replaced with the inches. So what we're going to end up getting is inches per minute. So what are we going to get? Well, it's going to be 360 pi, okay, times 28 inches, and that's going to give us, excuse me, oh wait a minute, no, I almost made a mistake. This is diameter. I almost made a mistake. So this is diameter, which means I don't want this. It's not the radius. Radius is half of this. See, I almost made the mistake. Don't make that mistake. Okay? The problem gave us the diameter, which is 28 inches, but we need to put in the radius. So this will give us 3,060, 720, 1440. Oh. Yep. Oh, hold on. Okay. And of course, this is inches per minute. Okay, so now that's what we have. Now we can go ahead and change this to miles per hour. Now that we've got inches per minute, now we can go ahead and change it to miles per hour. And so let me do that up here. Okay, so this is going to be 40. So 5,040 inches over minutes. And so now I'm going to multiply this by, now this is where I'm going to go from miles. So let's do the numerator first. Let's change inches to miles. So there's 1 foot, right? So 1 foot is equal to 12 inches. So inches cancels with inches, and we've got feet. And now I want to go to miles. And so there's 1 mile is equal to 5,280 feet. So feet cancels with feet. And now I can deal with the minutes, because now I've got miles on top. And so now I need hours on the bottom. So now I'm going to use the fact that there are 60 minutes in 1 hour. And then minutes cancels with minutes over here. And if you look at the dimensional analysis, I've got miles over hours. So now I just have to multiply across the top, right? And multiply across the bottom. And so that's going to give me 5,040 times 60 divided by 12 times 5,280. And if I put this in my calculator, so now the speed of the bike is approximately 14.99 miles per hour. 14.99 miles per hour. All right. And that's how you do it. Have a great day.